Hello again, and this video is going to be talking about measurements and perimeter area and volume. I would highly suggest that you go to Google and pull up measurement conversions sheet and geometry perimeter area volume. And you'll come up with some handouts or sheets that you can print out like this. I'm keeping this simple. I'm showing you how to do the things. I'm not showing you, what's the best handout, stuff like that. So if you have a book, then you might want to use the one that's in the book that you're using. But I just wanted to show you that you're not going to be able to do a lot of these conversions without the help of the handouts, especially conversions of US linear measurement to the metric system, because you're going to have problems. You're not going to memorize all those. And with the volumes, most of you will know the perimeter and the areas and the volumes of your rectangles, squares, and triangles. But when you get to the other type of shapes, you might forget some of those. So as we are doing the problems with measurements, I'm mainly going to hit metric, and I'm going to hit area, volume of a square and triangle and things like that. I'm going to hit the high points. You need to have a couple of these in your notebook, no matter, whatever you're taking math-wise. It's always helpful to have these two handouts in your notebook, or something like these two. So, with that being said, I'm going to just look at the U.S. I'm not going to spend a lot of time on the U.S. measurements, because most of us grew up knowing that there's 4 quarts in a gallon, and we know that there is 2,000 pounds are in a ton, and we know that 12 inches are in a foot. There's a lot of these, and these are your, and I'm going to highlight these. These right here, I think most of these, oops, not black. Let's not use black highlighter, Hubert. I'm going to use green because it's bright. And I'm just going to highlight these because most of these are standard. We call them standard or US measurements. And then I'm not going to spend a lot of time on those, because if I know that there's 4 quarts in a gallon, and I know that I have 3 gallons, that means 12 quarts. I'm not going to spend a lot of time on that, because that's a lot of basic math. I would like to mention a couple of things. I think it's very important that 5,280 feet is equal to a mile. I think that's important. That's one thing that we forget. And I don't see area up there, but I'll write that down in just a minute about an acre, because I think it's important that people know how much an acre is. We'll get to that when we get to the area. But I think most people need to know that 5,280 feet is equal to a mile. And some of those you can remember, and some of them you might need to write down to try to remember. But I'm not going to spend a lot of time on the standard. What I am going to do is talk about King Henry dyed drinking chocolate milk. King Henry dyed, meters, liters, grams, drinking chocolate milk. Now, of course, some of y'all have not heard that. Y'all have heard some different, whatever you want to call these things. But basically, the good thing about the metric system is easy to convert because all you have to do is move the decimal. Now, some of you that go into your sciences, you're going to have 2 or 3 out here that you're going to learn. Pica, Meca, and all those, and nano, and that's, you multiply by 10 to the second, 10 to the third, 10 to the fourth. But we're not going to worry about those because that's after you get in depth with your science courses. We're going to just basically talk about the basics. This is kilo. This is hecto. This is deca. This is deci. This is centi. And this is milli. Okay, now if you're talking about meters, that's kilometer, hectometer, decameter, decimeter, centimeter, and millimeter. If you're talking about liters, kiloliter, hectoliter, decaliter, deciliter, centiliter, milliliter. If you're talking about grams, kilogram, hectogram, decagram, decigram, centigram, milligram. These are your units. These are your basic units right here. Okay? Now I'm going to do a few conversions, and we're going to see how to do this. So if I want to change 3 meters into blank kilometers or kilometers, however you want to pronounce them, what I do? Well, you know that the decimal is right here on the whole number. So you first find your decimal. So I'm going to put over here, number 1, find your decimal. And on a whole number, it is right here. So that's number 1. Second, you want to go to King Henry died drinking chocolate milk and find where you start and go to where you finish. What are you talking about, Hebron? Well, we are at meters. We are at meters, so that's where we're starting. So we're going to start right here. And where are we going to finish? Where you're going to finish, let's put start right here. And finish right here. So I've got to move from here 3 hops, 2, 3. So I've got to move my decimal 3 places to the left. So move 3, or move from start to finish. And you do that with your decimal on your number. So I'm going to put 0.3 right here, or 3 point, and I'm going to move 3 places to the left. 1, 2, 3. I'm going to put the decimal there, and I put zeros right here. So 3 meters is equal to 0.003 kilometers. And that's how you use the metric system. That's how you convert from meters to kilometers. Let's change from milliliters. Let's go, I've got 200 milliliters. And I want to change that to liters. So where is the decimal on the 200? The decimal is right here. So where do we start? We start at milliliters, and we're moving to what? Meters, or liters. 1, 2, 3. So I got to move 3 places to the left. 1, 2, 3. So 200 milliliters is 0.2 liters. And yes, it works both ways. It doesn't matter. It depends on where you have to start and where you have to finish. So let's do another one. Okay, let's go. I'm going to start with 2 decameters or decagrams. I don't really care which unit you use. Equals blank centigrams. Okay, so where is my decimal on 2? My decimal is right here, and I'll do that in red. There's my decimal. And let me erase the previous problems we did. Let me erase that. And erase this. Now, I'm going to move. Where is decagrams? Decagrams is right here. So there's my starting point. And I've got to end at centigrams, which is right here. So I'm going to move 1, 2, 3. So I got to move 3 places to the right. So here's my 2.0. 2.0. I'm going to move 1, 2, 3. So 2 decagrams is equal to 2,000 centigrams. Let's do another one. I'm going to let you do this one. Pause the video and you do this one. Let me erase everything. I want you to do 3 or 5 kilometers equals blank meters. 5 kilometers. So pause the video and try that problem. So here we go. I'm going to put my starting point at kilometers. And I'm going to go to, there's my starting point, and I want to finish with meters. 1, 2, 3. So I'm going to move that decimal on 5. 1, 2, 3. So 5 kilometers equals 5,000 meters. So when you're talking about, changing from metric to metric, it's not that big a deal. You just use King Henry Diet Drinking Chocolate Milk. You find your starting point, you find your finishing point, and you move that decimal the same direction and the same amount of space as your start to finish. And that's how you change from metric to metric. Okay? Next thing I want to show you is area. Well, I want to show you temperature. So let's go to temperature because you might see this on a test or a standardized test. And I'm going to pull it up right quick for you. In that previous, and sometimes, let me pull that problem up. I meant that sheet. If you look, it's down here at the bottom. It talks about temperature. To convert a Fahrenheit temperature to centigrade, you do the following. You take your Fahrenheit, subtract 32, multiply by 5/9. So I'm going to give you that formula as you will see it in, you're not going to see that. You're going to see a formula. Okay, so I'm changing from Fahrenheit to Celsius. And that's going to be, I'm going to put Celsius is equal to, it says take Fahrenheit and subtract 32 and multiply by 5/9. So that's that formula. And then Celsius to Fahrenheit, I'm going to multiply 9/5, let's say 9/5. Okay, I'm going to take Celsius plus 32 and multiply by 9/5. And that's Fahrenheit. Now, you can also find these without having to do that. I'm just going to pull one up, and I'm just showing you this because a lot of this stuff you can pull up with Google, and you can, find a lot of the stuff yourself. But I'm just going to do temp conversion formula. There they are. Now, it's however you want to do it. I'm going to go here and maybe find a better, there we go. I'm trying to find the easiest one to, I really don't want, let me hit that one and go to snip. Do this for you right quick. There we go. Save as temp. Now that's a whole lot easier to look at. So let me just clear this and bring that in, and that way you can use it and put it in your notes for later on. There you go. And that, I'll make it a little bit bigger for you. And you might see it written a little bit different. I'm not gonna split hairs. You might see the Celsius written a little bit different. Celsius is equal to 5/9. I think this is how I had it written. F minus 32. And the other one is Fahrenheit is equal to 9/5 C plus 32. You could do that if you wanted to. It's not, that's basically it. And I'm just going to give you two problems because it's plug and chug. There's not much math here except you need to plug and chug. So I take, you measure somebody's temperature, and their temperature on the thermometer reads 98.6. 98.6 degrees Fahrenheit. Okay? And you want to change that to Celsius. So you plug it into this formula. And that's going to give you C is equal to 5/9 times 98.6 minus 32. Now, of course, unless you're Rain Man, you're going to do this on the calculator. So what I'm going to do is I'm going to pull up the calculator. Sorry. Should have already had it pulled up. My bad. And I'm going to click it in. 98.6, 98 98.6 minus 32 is equal to that. And I'm going to multiply that, parentheses, by 5 divided by 9, close parentheses. So 37 degrees Celsius is equal to 98.6. C is equal to 37 degrees Celsius. And 37 degrees Celsius is equal to 98.6. And that's how you use the conversions. So let's do a Fahrenheit from Celsius. So let's say that let's go with, I'm trying to think of a good temperature to use. Well, 37 is 98. So let's do 212 degrees Celsius. So I'm going to erase all this. So 212 degrees Celsius, or 212 degrees Celsius is equal to how much Fahrenheit? Okay. So we're going to plug, since we want Fahrenheit, you're going to plug 212 into this formula. So that's going to give us 9 over 5, parentheses, times 212 over 1. Notice I made that a fraction just to make it easier for you. Plus 32 degrees. And of course, again, I'm going to give you permission to use a calculator with this, because most of your conversions with temperature, you need to use a calculator for accuracy, and you're doing a lot of big numbers. So I'll give you permission. So 212 times 9 divided by 5, and I just did the fractions in my head, and then plus 32. So 212 degrees Celsius means that you're at 413.6 degrees Fahrenheit. 413.6 degrees Fahrenheit. So let's try a couple more. And I'll let you let's go with 0 degrees Fahrenheit. I want to know how much that is Celsius. Okay? And then let's do 12 degrees Celsius into Fahrenheit. And I'll bring in those. There we go. All right, pause the video and work on those two problems. All right, so I'm given 0 degrees Fahrenheit, so I'm going to plug that 0 degrees Fahrenheit into that equation. 0 minus 32 times 5/9, negative 32 times 5/9. So I go to my handy dandy calculator and I'd go 5 divided by 9, and multiply that by negative 32. Multiply by negative 32. I get negative 17.78 degrees Celsius. Negative 17.78 degrees Celsius. And now I'm going to change the Celsius into Fahrenheit. So I'm going to take that 12 and I'm going to plug into this one. So that'd be 9/5 times 12 and then plus 32. So take 9/5, 9 divided by 5, and I'm going to multiply by 12. Multiply by 12 and add 32. So 12 degrees Celsius is 56.6 degrees Fahrenheit. And that's how you use the conversion, the temperature conversion table. The temperature conversion formulas. Now, the third thing we're going to talk about is we're going to talk about area, perimeter, and volume. And I always tell students that if you buy a piece of land, usually you buy a piece of land, and if it's a small piece of land, it looks like a rectangle. And you buy that piece of land, and let's say it's a ½ acre or an acre. The first thing people are going to do when they buy a piece of property is they put up a what? They put up a fence. And there's a gate right there. Okay, so they put up a fence. Well, think of the fence as the perimeter. Because what does the fence do around the property? It surrounds the property. That's what the perimeter does. And then you say to yourself, well, since I got a fence up, I want to put some cows out there, or some goats, or some horses. So I take my handy dandy green highlighter and we go out there and we cover our property with grass. And when we sow that grass, we have just done what? We've done the area. Because what did we do? We covered the whole property with grass seed. So the fence is the perimeter and the grass is the area. Well, then we get bored with the cows and we sell the cows and the goats and the horses. And then we decide, you know what? I want to make me a pond. I want to make a pond with my property. Oops. So I take me a backhoe or an earthquake, a track hoe or a whatever you want to call it, a backhoe, and I dig down 6 feet. And I take the garden hose and I fill it up with water. Well, when I add that third dimension of depth, because I had right here, I had length and I had width, or width and length. You can turn them around, it doesn't matter. Let me change that because some people will have conniptions because I made this the length. So we're going to call that width. And this is length. Here's my length, and here's my width, but what did I add? I added depth, okay? How something's deep, I added depth. And when I add depth, that's volume. And it's got 3 dimensions. Let's talk about dimensions. When I go around the property, what do I measure the property in? I measure in feet. Is there any other dimension? No. So then the unit is just going to be whatever you measure it in. It's one-dimensional. 2 dimensions is length times width. Length times width, you have 2 dimensions. So in that case, you're going to have feet squared. So that's going to be your label for area. Your label for perimeter is just feet or meters or whatever you measure. Volume has 3 dimensions. Length times width times height, or in this case, depth. And that is 3 dimensions, so it's going to be cubic feet. So whenever you're looking for a test on a test or a homework assignment or whatever the case may be, and you see feet, then you know that's probably perimeter. If you see square feet, you know that's area. And if you see cubic feet, you know that's volume. And volume is either going to be the height of a building or the depth of a pool of water or pool or pond, whatever you want to call it. Okay, so you have the perimeter, which is a fence. You go out and you throw grass seed all around your property, that's area. And you dig down 6 feet and fill it full of water, you've got a pond, which is volume. I always tell my students this because that way they can go ahead and decide in their head what they are looking at. Now, of course, you can do it with a rectangle, a triangle, all that good stuff. And that's what the formula sheet's for. We're going to take a minute and go over just 3 or 4 type problems so you can actually see how to do these problems. So let's go ahead and start with something real simple. And let's go with a piece of, I'm in a square, I'm in a rectangle that is 4 feet by 6 feet. Well, the area, the perimeter, the area for a quadrilateral perimeter is equal to 2 times L plus W, or 2L plus 2W. Now, let me also say that you can also see base times height. Base times height, length times width, that's the same thing. So I don't want anybody thinking that length and width is different from base and height. The perimeter can also be written as 2 base plus the height, or 2B plus 2H. Base and height, length and width, tomato, tomato. It doesn't really matter what you call it. That's the perimeter. So in this case, 2 times 6 2 times 6 plus 4 is 2 times 10, which is 20. So if you wanted to put a fence around this piece of property, or whatever this is, garden, you would need at least 20 feet of fencing to go around this property. And again, we would say 20 feet because it's measured in feet. If it was millimeters, it would be mm. If it was inches, you would put 2 little marks instead of 1. Well, what about the area? Let's say we cover this garden spot in grass. Well, area of a quadrilateral is equal to length times the width, or base times the height. length times width, or base times height. So that's going to be 6 times 4, which is 24 square feet. Always remember, when you're finding the area, you have to go with square feet versus feet. Feet is perimeter, square feet is area, and then cubic feet is volume. Let's say you're making a fish pond for your goldfish. You're going to put a fountain in it. Okay, so here we're going to draw the same not an artist, but it's, makeshift. And we're going to dig that, we're going to dig it 3 foot deep. Well, you still got your length and your width. Your length is 6 and your width is 4. So now you find the volume of a rectangle. Volume of a rectangle, or a quadrilateral, is equal to length times width times height. And in this case, the height would be depth because you're digging into the ground. Height and depth, tomato, tomato. Okay, so that's equal to 6 times 4 times 3, which is 6 times 12, or 24 times 3. Either way, I think you get 72, because 6 times 12 is 72, I believe. And that's cubic feet. So if I wanted to know how much feet of water this would hold, it's going to hold 72 cubic feet of water. And that is how you find, now again with a square is a quadrilateral. If you had a square 2 foot by 2 foot, then it'd be easier. You could say 2 squared, and then 2 times 4 would be your, so 8 would be your, so with a square it's a whole lot easier because you got the same number. But both of these are quadrilaterals. And if they're both quadrilaterals, you're going to use the same formulas. What about a triangle, Hubert? Well, a triangle is like so. I'm just going to use just a regular triangle because I want to show you where the formula comes from. There's a quadrilateral. So if I take half of that, if I draw a line right here, then technically a triangle is half of a what? A rectangle. So if a triangle is half a rectangle, then technically half of the area of a rectangle is the area of a triangle. So the area, the perimeter of a triangle, I'm trying to think how to write, is 3 sides added up. So add the sides, A plus B plus C. A plus B plus C. Now we're going to find out how to find C here in just a minute, if it's a right triangle. Okay? The area of a triangle is equal to 1/2 length times width, or 1/2 base times height. I don't care what you call base times height, length times width, that's fine. Or in this case, 1/2 A times B, since I've labeled these A and B. And the volume would be the same thing, only you add a depth to it. Okay, so I'm going to go back right quick. Let me pull up that. And that's why it's so important to have a handout. There we go. Because it's easy to keep it organized. There we go. And there are the two, those are the two formulas that we use there. You don't see a lot of volumes with the triangle because not many people do that, but you would do 1/2 base times height times the depth. Okay, so volume of a triangle. So the volume of a triangle would be the length, width, and height of a rectangle divided by 2. So 1/2 base times height times depth, or length times width times depth. Doesn't matter. In this case, 1/2 A times B times, I'm going to call it depth. Okay? A times B times D. So if I had a rectangle like this, and, well, I can't draw worth a flip. Here's your A, B, C, and then your depth would be, think of a piece of pie. Okay? It would be that. And of course, you see we've went over a square, we've went over a rectangle, which is the same thing, and we've went over now, I do want to show you the Pythagorean theorem, because the Pythagorean theorem is how you find that angle C if it's a right triangle. It's got to be a right triangle. And if it's not, then they give you angle C. All right? They give you side C. So I just wanted to go over that with you. I'll go over that right quick. Let's say we have, let me erase this over here. Let's say we have a triangle. Oh, man. Let's say we have a triangle, and we've got, it's a right triangle, and that's very important. And there's a right triangle, and we've got a side of 8 feet and a height of 6 feet. Then we can plug it into the Pythagorean theorem to find angle C. Angle C is always called the hypotenuse. And it's always the longest side. And it's always across from the 90-degree angle. So you always can find the hypotenuse when you're given the 90-degree angle right here, and you notice it's going to be the longest side, and you plug it into the Pythagorean theorem. So if we solve, the Pythagorean theorem says a squared plus b squared is equal to c squared. That's the Pythagorean theorem. And if I want to get c by itself, and this is your algebra, I take the square root of both sides. So c is equal to the square root of a squared plus b squared. And you're going to see that later, but I just want to show you in a case where they don't give you c, either they're going to give it to you or they're not with a 90-degree angle. And if they give it with a 90-degree angle, then you use the Pythagorean theorem. And you would plug in 8 squared plus 6 squared, and then you would do it on the calculator. That would be the square root of 64 plus 36 is equal to C. The square root of 100 is equal to C. 10 is equal to C. So now we know that C is equal to 10 feet. And then you just plug and chug. If I want to find the volume, I meant the perimeter, that would be, perimeter of this triangle would be 6 plus 8 plus 10, which is 24 feet. And the area of this triangle, 6 times 8 times 10. 6 times 8 is what? 48 plus 10 times 10 is 480. So that's 480 divided by 2, which is 240 what? Square feet. So if you wanted to paint this triangle, you would have to get enough paint for 240 square feet. If you wanted to paint a wall that was a triangle shape, you would have to have 240 square feet of paint to paint that wall. Okay? And if you had a volume, let's say this was a piece of pie, or let's say it was let's say you built a frame for a garden. And let's say that the depth of this garden or this box is 3 foot. Then the volume of this frame, this wooden frame, the volume of this triangular frame would be 1/2 times 3 times 8 times 6. And 3 times 8 times 6 is the volume of the rectangle, and then you would divide that by 2 because a triangle is half of a rectangle. So 6 times 8 is 48. 48 times 3 is 144, I think. And then half of 144 is 72. 72 cubic feet. Of course, you need to check my math. I'm not, let's see, 3 times 8 is 24. 24 times 6. Let's pull out our handy dandy calculator and let's check that one. I think I've got it halfway decent, but I want to make sure. Pull up our handy dandy calculator and let's do, let me turn it on. Okay, doing this with the mouse is very, you'll have to excuse me for a second. Sometimes the stylus doesn't work with me on the, there we go. All right, I'm going to take 3 times 8 times 6, 3 times 8 times 6, and divide that by 2, 72. So, and that is how you use, that's how you use perimeter, area, and volume with a triangle. Now again, I'm going to pull up the chart because you need to make a note of the circle. And the reason I'm pulling it up is because I don't, it don't matter to me whether you use but you need to know, let me move this over. Hold on a second, people, sorry. There is the circle. Right here, perimeter of a circle is equal to 2 pi r. The area of a circle is equal to pi r squared, where r is the radius. Now, the reason they don't have volume there is because when you get to volume, you have to do a sphere. And the area of a sphere, I'll just draw what looks like a pumpkin. In other words, the area of a sphere is going to be 4 pi r over 3, or 4/3 pi r squared. And there are your 3 formulas for the area of a, and the only thing they're going to give you is r. That's the only thing they're going to give you. They're going to say a radius of equal to 6 feet. And then you plug them in. So the perimeter, if you put a fence around, let's say a dog, if you want to put a dog fence around this perimeter area 6 feet, then the perimeter of that fence, how much fencing do you need to have to go around a 6 foot, would be a 12 foot in diameter, because R is 2R is equal to diameter. a 12-foot diameter dog pen, all right, what would that be? How much fencing would you need? Well, 2 pi times 6 is 12 times pi. Now, what do you use for pi? When you use pi in calculations, you got 3 choices. You can use 3.14, you can use the pi key, or you can use, 22/9 or something like that. I can't remember what it is. I would highly suggest that you use pi. So let's go ahead and do that. On your calculator, you need to find pi, and I think, because I can't see this very well, I think it's the square key, which is right here above the division symbol. Let's see, 12 times pi second, caret symbol. So the perimeter is 38 feet. Well, 37.70. But you're not going to ask for 37 feet, 0.7 feet of fencing from Lowe's. You're going to want 40 feet. And then you're going to, if you get them in, in 10-foot sections, you're going to get 4 pieces and you're going to put them, well, that'll be a square, but if they come in 2-foot sections, you're going to get 40 feet, that would be 20 sections, and by the time you put them in place, you'll have a circle, okay? So 37.7 feet is your perimeter. 37.7 feet is our perimeter. Area. Area is going to be pi times 6 squared, which is 36 pi. And we'll go to our handy-dandy calculator and do 36 times 7 second pi. So if I wanted to paint the circle that is made by, or put seed in the circle of my fence, dog fence, then I would get enough paint or enough grass seed to do 113 square feet. 113.09 or 0.10 feet. Square feet, sorry. Well, what if we just made the dog pen into a spherical cage, like they ride the motorcycles in at the circus? Then we would multiply 4/3 times pi times 36, which is 6 squared, and then you would get 36 divided by 3 is 12, 12 times 4, 48 pi. So if we wanted to fill that cage up with water, we would get 48 pi. So that would be 48 times second pi. That'd be 150 cubic feet, 151 cubic feet. So that would be equal to 151 cubic feet of water in that cage if you was to make it look like this, with a 6-foot radius. So with a circle, you only have to have one thing, and that is the radius, and you plug and chug. And that is measurements as well as geometry, including perimeter area and volume.